starting with your basics and yes. So what are we going to see today is, again, as I said, my first thing that I wanted to touch upon was the signals, right? So the signals are very, very important, and we're just going to see the basic signals for this particular chapter. Okay. First of all, the references text that is essential for you all. John Proakis. Proakis is the Bible for digital signal processing. So Proakis, I need for digital signal processing. The author is Proakis, John Proakis, right? Your book is available in the library and you can access it. This is if you learn digital signal processing from Proakis, nothing better than that. Yes, and similarly for image processing, I have a standard textbook, that's Gonzalez. Right, so these are the two standard text the reference textbooks that you all are going to refer for signal processing and for image processing, right? And on this note, if I can continue, so let me just come to the digital signal processing and what are the kinds of applications that ma'am is talking about when ma'am is speaking a lot about digital signal processing. So this being my digital signal processing. So what are the applications that ma'am is going to talk by when she's talking continuously about signal processing, right? So I have got communication systems. Do you agree? Your mobile communication system, your wireless communication system, your wired communication system, right? So I've got noise modulation, demodulation kinds. Then I've got channel equalizers. Then I've got echo cancellation, right? Noise cancellation. So nowadays, whatever Bluetooth, I repeat, the Bluetooth headphones. The Bluetooth headphones, they talk more about noise cancellation. Have you heard about this? They all the vendors are very much into noise cancellation. Have you heard about this? Bluetooth headphones, they say that
Yes, ma'am.
they say continuously that इसका noise cancellation उस वाले product से better है और इसमें noise cancellation नहीं है, इसमें noise cancellation सबसे ज़्यादा है. So what is this noise cancellation? What are we exactly talking about? Can somebody respond? What is this noise cancellation in my headphones?
When music is played, the
Uh-huh.
noise is cancelled, and so that music can be heard very more clearly.
Okay, so what noise am I talking about here?
Outdoor noise.
Background noise.
So if
Background noise.
if I am speaking, I am also using a headphone right now, right, earphone right now. So is there any noise from the background?
No.
No, ma'am.
No noise, right? So
No, ma'am.
that's noise cancellation. So some of the headphones that are cheaper possibly doesn't have noise cancellation, do they? सारा फीचर्स कवर नहीं होता है ना. So that is one application to my digital signal processing, right? To cancel the background noise. Next is my consumer electronics, wherein I have coding of audio and video. So I've got DVDs, I've got speech synthesizers, I've got speech recognition, right? So these kind of softwares. Can I get one example of speech recognition? स्पीच रिकॉग्निशन मतलब जो मैं बोलूं वो उसको पता होना चाहिए कि मैम क्या बोल रही है. सो कैन आई हैव वन एग्जांपल ऑफ स्पीच रिकॉग्निशन?
Google voice search.
Google
Alexa.
voice search, Alexa, very good.
Siri.
Alexa. So these are very good examples of speech recognition, right? Next we come to music. We have got synthetic instruments, right? Audio effects, noise reductions, right? So ये आपके music composers, the people who try to make are into music industry, they are using many kinds of synthesizers, basically music synthesizers, right? And then I've got medical diagnosis where I use MRI, CT, and I've got CT, then ECG, then EEG, audiology, ultrasonic imaging. These are my medical diagnostics, right? And why am I using signal processing here? To get my to get the images clearly. These are different imageries, right? MRI is a different kind of imagery, then CT is a different kind of imagery that is being used for diagnosis, and ECG is altogether a different kind of graphical imagery that I have, right? And so these are important and they have to be very very clear. So that's why medical diagnostics. Next comes geophysics, wherein I talk about seismology. So seismology is basically what? Can somebody touch upon what seismology is? Seismology is
Study of earthquakes.
uh-huh.
Study of earthquakes.
Yes, yes, very nice, very nice. So that is basically, basically we are trying to understand where do I have a history of earthquakes, and so basically in areas where there are frequent earthquakes, I need to have a seismology department out there. Next comes my astronomy, when I'm going to touch upon digital signal processing. Then experimental physics, when I talk about sensors could be anything. Sensors could be audio, sensors could be video, sensors could be images, so it could be anything. So these are different sensory data, right? Next is aviation, when we have radar navigation and radio navigation. So these are basically frequencies that we touch upon, right? Next is security, your cyber security, your network security, wherein we have steganography, watermarking, biometric identification, surveillance systems, so on and so forth. And next is when I have take my engineering into consideration, wherein I'm basically trying to do some pattern recognition. Got it? So these are the various applications for my digital signal processing. अब इन सारी applications में एक चीज common है students, and what is that thing? What is DSP? DSP is digital signal processing. Which signals are we trying to analyze?
Digital signal.
डिजिटल सिग्नल्स वी आर ट्राइंग टू एनालाइज. बट जो भी मैम यहाँ पे एग्जाम्पल दे रही है, ये सारे डिजिटल सिग्नल्स हैं क्या? कम्युनिकेशन सिस्टम डिजिटल है क्या?
No.
हाँ
जब आप बोल रहे हो, नहीं, सपोज इन मैम इज टॉकिंग राइट नाउ, तो वो मैम कौन से सिग्नल्स थ्रो कर रही है? ऑडियो,
Analog.
ऑडियो ना, ऑडियो और एनालॉग सिग्नल्स थ्रो कर रही है. बट जब मेरा हेडफोन उसको कैप्चर कर रहा है, ठीक है, और वो जब आप माइक्रोफोन से मैं बोल रही हूँ और वो कैप्चर हो रहा है और वो आपके पास आ रहा है, तो वो किस में आ रहा है?
Digital signal.
डिजिटल में आ रहा है. Got it? And then I am trying to, with the moment I'm capturing these analog signals, I will convert it into digital and I do then some processing on it and then I transfer it to the other end. Is that clear? So that happens in all the cases. Let it be medical diagnostics also. CT, MRI signals जो है, we try it on a real person, right? And when we are doing the diagnosis on a real person, those signals are analog and then they are getting converted to digital and then they are processed and then they are being used by the applications. Clear? So on and so forth. Likewise for all the applications that we have seen here. Is this clear to everyone? What are we touching upon? DSP, applications.
Yes, ma'am.
Right. Yes. Okay.
Yes.
Now, can somebody tell me what are the different image processing applications? मैंने जानबूझ के blank रखा है so that we understand what are the image processing applications. Can somebody respond? एनी एप्लीकेशन जो तुम्हारे दिमाग में आ रहा है. आप मोबाइल यूज करते हो, आप फेसबुक यूज करते हो, आप इंस्टाग्राम यूज करते हो. मैं सिर्फ सोशल मीडिया टच कर रही हूँ बिकॉज हम सोशल मीडिया पे ज्यादा रहते हैं इसलिए. सो कैन समबडी टच अपॉन सम ऑफ द एप्लीकेशंस दैट यू सी इन योर सोशल मीडिया इन योर डे टू डे लाइफ एंड
मैम फिल्टर्स ऑन इंस्टाग्राम.
Okay, so very good. So he's saying that filters on Instagram, or let me just say filters on images. Okay. Okay. So applying filters on images could be one application of image processing. Any second application of image processing?
Grayscaling an image for training and model.
Grayscaling of, okay, so that's a filter only, no? So I need to convert my image to a grayscale image. So that's a filter basically that we are applying. Yes. Anything else?
Editing image in Photoshop.
Editing image on Photoshop. So what are we trying to do here? So Photoshop is a good application of image processing only. Okay. Yes. Something else?
Pattern recognition.
Oh, good. That's facial recognition. So face recognition that is happening on my phones nowadays for
Google
authenticity.
Photos.
Google Photos, and what are we going to do with this Google Photos?
फोटो सर्च के लिए फेशियल रिकॉग्निशन वाला
ओके, फोटो सर्च के लिए फेशियल रिकॉग्निशन का एप्लीकेशन यूज करके फोटो सर्च होता है ना? You want
गूगल
to touch
फोटोज
on
में.
that? Okay, good. Can I expect some more answers? Can I say segmentation of images? That is very essential. ये आप लोग यूज भी करते हो, segmentation of images. Segmentations of objects to get object. Okay, let me just put it like object recognition. Object recognition. Yes. Anything else?
गूगल लेंस.
Google Lens. Okay. So he wishes to say Google Lens.
रिकॉग्नाइज एनी ऑब्जेक्ट, एनी
Oh, that's object
टेक्स्ट.
recognition. Text. So text for what? Text. What are we going to do with that text? So you want to say text recognition. Text recognition, but text has to be in images format, right? Text recognition when we are trying to do that, but taking images into consideration, yes. Okay, now can I also add some data visualization here? ये पता है किसी को? Data visualization very happening nowadays into data analytics.
Augmented reality.
नहीं, data visualization. Data visualization wherein I have got different Tableau, Power BI. Tableau किसी ने देखा है? Tableau.
Yes, ma'am.
हाँ, क्या होता है उसमें पता है? ग्राफ्स बनते हैं ना, बहुत अलग अलग तरीके के ग्राफ्स बनते हैं.
डेटा एंटर करते हैं और फिर कोई
हाँ.
फॉर्मूला डालते हैं तो ग्राफ बनते हैं.
हाँ, तो ग्राफ बनते हैं. Yes. Anything else? Somebody said one more thing.
Augmented reality.
Augmented reality. What am I going to do? Images there. Image processing क्या use करेंगे हम वहाँ पे? Augmented reality. Okay.
नॉर्मल इमेजेस को वर्चुअल इमेजेस में कन्वर्ट करके
Then QR जनरेट करके लेयर बना के वैसे बोल रहे हो आप? हाँ, ठीक है. Okay. There was one more student was saying gaming.
गेम इंजन.
Game. Yes,
Game engine.
Game engines. Okay. Yes. So these are the applications that we all are facing in our day-to-day lives, right? मतलब इसमें से कुछ ना कुछ तो हम majority सारा कुछ use कर ही रहे हैं to get my images being enhanced, being processed quickly, and then I it is ready to use for my applications, right? So good to go, and very nice that we have got so many applications that we can write upon when I'm talking about image processing applications. इसमें आप एक वो भी डाल सकते हो. अभी किसी ने बोला था, I just missed out, medical applications, CT, MRI, X-ray are very essential applications for image processing. Then we have got radar images also, satellite images, radar images as well for processing, for defense applications, for geo survey applications. So these are the kind of applications that we are going to deal with, right? Okay. So let me just touch upon what is signal processing and where are these signals. Yes. So do you believe on the first point that ma'am is mentioning that humans are the most advanced signal processors? Do we agree to this point?
Yes, ma'am.
Yes. So we are the most advanced signal processors because we can do speech recognition also. We can do pattern recognition also. We can do image recognition also, object recognition as well, speech synthesize as well, modulation, demodulation भी voice का हम कर सकते हैं. So we are the most advanced signal processors. So what are we expecting the machines to do? We are expecting the machines or as the digital signal processors to do something what we are doing basically. So if I give an audio signal to my system, so if I give an audio signal to my DSP system, what am I expecting the output as? I am expecting the output could be a text, audio to text converter, speech. ये क्या किया मैम ने? ये speech recognition किया. समझ आया सबको? मैम उसको टेक्स्ट में कर रही है ना, ऑडियो टू टेक्स्ट कन्वर्ट कर रही है, वॉइस टू टेक्स्ट कन्वर्ट कर रही है, राइट? बट उसके लिए मुझे डीएसपी सिस्टम लगेगा ताकि मैं वो ऑडियो को एनहांस कर सकूं अच्छे से, उस सिग्नल्स को एनालाइज कर सकूं, एंड देन आई कन्वर्ट इट टू अ टेक्स्ट. ऑब्वियसली only DSP is not essential. I'll be needing my machine learning algorithms and AI as well to convert my audio to text out here. Got it? Yes. So this is one thing that we wanted to touch upon. So there are many types of signal, students, right, in various applications that we deal with. One is the electrical signals that we deal with. Number one, electrical signals in terms of voltage, in terms of current, in terms of magnetic and electric fields, right? Second is the mechanical signals that we touch upon. So the mechanical signals are velocity, force, displacement, pressure, whatever we are learning on this. Now my third is acoustic signals, that is sound, vibrations, right? And number four is other signals that we touch upon, that is pressure, temperature, so on and so forth. Do we agree to all these kinds of signals that we deal with? ये सारे सिग्नल से हम कुछ ना कुछ डील करते ही हैं, yes or no? Electrical signals, mechanical signals, acoustic signals, and there are different other signals, right? The most real world signals that we are talking about are what in nature? Are analog in nature. Right? Now, when I say an analog signal means they are continuous in time and amplitude. So the best example of an analog signal is this an analog signal? जो मैम ने ड्रॉ किया.
Yes, ma'am.
Yes.
Okay. Why am I saying this as analog signal? Because this is what in nature? This is continuous in nature, right? And then we see what is this time and amplitude later on. Okay. Now convert to voltages or currents using sensors and transducers, right? So we are trying to convert this analog signals into different other formats, and then we're trying to use it. Okay. So analog circuits process these signals. अगर एनालॉग सिग्नल होगा तो उसको प्रोसेसिंग के लिए एनालॉग सर्किट्स लगेगा. एंड व्हाट आर दीज एनालॉग सर्किट्स? Analog circuits, have you seen this kind of circuits when you were doing your, ऐसा कुछ किया होगा ना?
Yes, ma'am.
Yes,
है
ma'am.
ना? ये मैं एक
Yes,
एग्जांपल
ma'am.
दे रही हूँ, आई माइट नॉट बी करेक्ट. नहीं, ये क्या होता है? ये एक स्विच होता है, स्विच होता है ना? व्हाट इज दिस? रेजिस्टर,
Register.
Resistor.
है ना? और यहाँ पे मैम ने क्या ड्रॉ किया है? कैपेसिटर,
कैपेसिटी
है ना? तो ये एक तरीके का एनालॉग सर्किट है. तो इसमें इनपुट क्या जाएगा? डिजिटल जाएगा क्या? नहीं, इसमें इनपुट क्या जाएगा? एनालॉग सिग्नल इनपुट जाएगा. यस और नो? और एनालॉग सिग्नल कैसे दिखेगा? ऐसे कुछ दिखेगा. ये अगेन एक एग्जांपल है. Right. So if I give this analog input here and then it passes through the resistor, and similarly what not happens out here. So what is the output that I'm expecting? The output क्या आएगा? इसमें analog ही आएगा ना?
Yes, ma'am.
हाँ. So analog will be my output. Yes. So my analog circuit consists of resistors, capacitors, inductors, amplifiers. Got it? So giving an analog signal to my analog circuit, it processes it and it gives me the output. That happens. Signal processing analog circuit use करके भी होता है. Analog signal दिया तो भी signal process होके मुझे output आएगा analog. Enhanced output आएगा. Right? So analog signal processing examples are audio processing. Audio processing in what? Audio processing in your radios. FM radios. Then there is video processing in traditional TV sets. No, not nowadays TV sets that uses Geo and everything, but the ancient TV sets that were using antennas for reception of the signals for TV channels, and then they used to process my video signals. Right? Is this clear to everyone? Signal processing analog circuit se bhi hota tha. Right, but then what is the benefit of using digital? That is what we are going to touch upon. Right, so we have seen that there are various type of signals that we deal with, and most of these signals are analog in nature, and my analog signals can also be processed using my analog circuits that consist of resistors, transistors, capacitors, so on and so forth. Right, clear to everyone? Should we proceed?
Yes, ma'am.
Okay, nice. So what is a signal then? Can somebody say what's a signal? Forget about the definition जो नीचे दिया है. Signal क्या है? What is your understanding about a signal? what can I say a signal to be? Signal क्या है?
Ma'am, signal contains information.
Okay, so you want to say that signal. Let me just come to some definitions out here. Signal.
Transferring information from one place to another.
Okay, so so one definition I got it. Signal contains some kind of information. The second definition that I'm getting is when I want to transfer the information, right? Anything else? Signal क्या है? What's a signal? Then what is signal?
It is a digital variable that convert information into digital variable and then transfer through it.
Okay, so you want to say that a signal is a variable, है ना? A signal is
Yes.
a variable. Okay. Anything else? Anything else? What is a signal, students? Signal मतलब क्या? Signal मतलब क्या है? Real world में कितने सारे signals हैं? तो वो signals का meaning क्या है? Now, can I say that? Okay, so let me just talk about this. Can I say that measuring temperature is a signal? I'm just trying to understand. Measuring temperature is a signal. Can I say that measuring temperature is a signal? Or else, can I say that checking the audio output is a signal? Can I say these are signals? Measuring temperature or checking the audio output of any device? Yes or no? Can somebody respond? Are we there?
Yes, ma'am.
Huh. Can somebody touch upon this? Is this signals that ma'am is talking about? Okay, very so the student who said that contains information, good. A signal contains information, obviously yes. The second student who said that a signal is a variable, okay, good. A signal is a variable. There was one student who said that signal is basically transferring information from one end to another end. So I will put that as a system, not as a signal. Okay, signal can be transferred from one transmitter to a receiver, but for that I need to have a system in place. Okay, so so student, signal is any physical quantity that varies with time, space, or any other independent variable, right? So if I put now my example would be I will draw a signal here, right? And now my this signal varies with time. ठीक है, तो इसमें मैम के दो वेरिएबल्स हैं. एक तो मैम का इंडिपेंडेंट वेरिएबल है. इंडिपेंडेंट वेरिएबल क्या है यहाँ पे? टाइम है, राइट? और डिपेंडेंट वेरिएबल क्या है? जो मैम मेजर कर रही है वो डिपेंडेंट वेरिएबल है, right? And so this signal that I am getting is my dependent variable, and that's nothing but signal for me. Right. So, but then now this signal is dependent on which variable? On the independent variable, that is time. Okay. This could be, this y-axis could be temperature. Y-axis could be pressure. Y-axis could be the audio signal frequency. Could be the sound signal. Could be the color signal as well of a picture in space. Right, of a pixel in space, right? Is this clear to everyone? What's a signal?
Yes, ma'am.
Okay, so a signal could be anything that varies with time. तो उसमें दो variables होते हैं, एक independent variable जिस पे आपका signal depend करता है, और एक dependent variable जो आपका signal है. So whatever you are trying to measure, that becomes my signal. Okay, so if I'm trying to measure the pressure, then that pressure becomes my signal, right? Now, if I'm trying to get the sound, then sound becomes my signal. That's a function of time. If I'm trying to get the color, then color becomes my function of space, right? So a good examples for analog signals, since we are doing analog here. So good examples for analog signals is something like this. When I give my signal that varies with time is equal to cos 2 by t. Right. So this is an analog signal that I'm talking about. Now another example is my signal that varies with time again is 4 under root t plus t cube. This is another signal for me. Right. So these are the equations, these are the functions for the signal. Right. And on this basis, I try to get the waveform of the signal, since these are analog signals that we are talking about as of now. Okay. And next is my signal depends on two independent variables, m and n. Right? So it is m plus n the whole square in that case. Okay, so these are some good examples for signals. Now let us just come to what's a system then, right? A physical device that performs an operation on a signal. Like the student said, ma'am, अगर मुझे transmitter और receiver पे signal को transfer करना है, so in that case, I will be needing a system here, and that system is nothing but a physical device that is present to transmit my signal from the transmitter to the receiver. So basically I'm trying to do some operation on the signal, right? अब मैम ऑपरेशन यूज कर सकती है कि एम्पलीफाई कर सकती है सिग्नल को, मैम नॉइज कैंसिलेशन कर सकती है, right? So these are the good examples for a system in that case, right? And system जब एक सिस्टम रेडी होगा तो जब आपका कोई भी सिस्टम होता है, राइट, यू वुड हैव लर्न दिस इन योर सेकेंड ईयर ऑफ इंजीनियरिंग. अ सिस्टम नीड्स इनपुट एंड द सिस्टम गेट्स एन आउटपुट, राइट? तो सिस्टम को इनपुट क्या लगेगा स्टूडेंट्स? x, और आउटपुट क्या आएगा? y, right? So my y is dependent on what? Is dependent on x. So if you see the example of a system, the y out here, that's the output of the system, is dependent on x, right? और उसका independent variable क्या है? टाइम है, क्योंकि वो टाइम के बेसिस पे डिफाइन किया था ना हमने जो सिग्नल था वो, क्योंकि ये एनालॉग सिग्नल्स है इसलिए, राइट? इज दिस क्लियर? सिग्नल एंड सिस्टम, is this clear? Signal and system, students?
Yes, ma'am.
So what's a signal? Signal is a physical quantity and system is a physical device. So to get any signal, I need to have an independent variable and a dependent variable. And a system is when I am performing some operation on the signal, I need to have a physical device to perform it, and that physical device is called as a system. So what is digital signal processing? Digital signal processing is what? A signal or a system? Yes.
System.
Yes. Yes, it's a system. Right? A system to perform some operations on the signals, and after doing that operation, I'll get the output to that. Simple. So DSP is a system, and the signal that we are trying to give to that DSP is either an analog signal. Since it is digital signal processing, so I'll be giving what signals? Digital signals to it. Is that clear to everyone? What are we trying to touch upon? Signal system समझा सबको? Ma'am क्या बोल रही है? Right. So try
Yes, ma'am.
understanding these concepts very clearly. Okay. So let us just see what's an independent variable out here. क्या था independent variable signal में?
Time.
Time. Very good. Generally we use time as an independent variable. Generally, right? A signal can be represented as a function x of t, and it consists of one or more dependent variable components. ये x जो है ये dependent है, और ये t जो है ये क्या है? Independent है. So this is independent, and x could be pressure, could be temperature, could be my sound signal.
Color.
Yes, could be color, RGB color value. Got it, no? And the independent variable is time, or else the location, three-dimensional location that we have already done, or else it could be the space location, right? So generally we are going in for time as our independent variable. So henceforth, whatever we will be doing is on the basis of time only, right? Now let me just lastly touch upon what is this continuous time and discrete time signal. Continuous time versus discrete time signals, right? So continuous signals are obviously dependent. We are taking our independent variable as time, and x of t is the signal which is dependent on time, right? And a signal is defined for every value in time. So every value that I have here, and I'll just put it up like this. So each and every microsecond that I have here will have a value for it, a signal value for it. So that is nothing but with signal, continuous signal, right? And in this continuous signal, I will get a waveform. That is what you can see here, right? So I can say that this signal is a voltage. It could be height. It could be the number of positron emissions as a function of time. It could be anything. So these are continuous signals for me, right? तो अगर मैम ने बोला कि मैम टाइम कंसिडर कर रही है फ्रॉम 5 मिली सेकेंड्स टू 100 मिली सेकेंड्स, सपोज ये मैम का टाइम फ्रेम है, राइट? तो 5 मिली सेकेंड से लेके 100 मिली सेकेंड्स तक मैम को क्या आएगा? मैम अगर ले रही है वोल्टेज ले रही है उस टाइम पे, तो मैम को वोल्टेज आएगा एट एवरी पॉइंट शी इज गोइंग टू गेट दी वोल्टेज, राइट? तो मैम के कितने लोकेशंस आएंगे 5 मिली सेकेंड से लेके 100 मिली सेकेंड तक? कैन somebody touch upon this? How many locations will I have? How many time intervals will I have if I take every millisecond into consideration?
95.
95. ओके, सो मैम को कितना वैल्यूज मिलेगा इधर? 95 टाइम वैल्यूज मिलेगा, और 95 टाइम वैल्यूज पे मैम को आउटपुट क्या मिलेगा? वोल्टेज मिलेगा, यस और नो? सो दिस इज एक्स ऑफ टी, क्लियर? और टाइम वैल्यूज क्या है? 5 मिली सेकेंड से लेके 100 मिली सेकेंड से. सो दैट इज व्हाट वी मीन बाय अ कंटिन्यूअस टाइम सिग्नल, स्टूडेंट्स, right? And then what is my discrete time signal in that case? So discrete time signal is at particular intervals I will be checking the input. I won't be checking the input at every millisecond. Now say suppose my interval that I am choosing is 5 milliseconds का interval है, ठीक है? और मैम का ब्रैकेट यही है, मैम ने सिग्नल्स लिया 5 मिलीसेकेंड से लेके 100 मिलीसेकेंड तक. तो मैम का डिस्क्रीट टाइम सिग्नल क्या हो जाएगा? पहले मैम 5 मिली सेकेंड्स पे देखेगी, ठीक है? फिर मैम कब देखेगी? नेक्स्ट टाइम
10
पहले,
milliseconds.
हाँ, पहला मैम
10
ने 5 मिली सेकेंड्स पे वोल्टेज चेक किया, ठीक है? फिर मैम कब चेक करेगी? 10 पे चेक करेगी. उसके बाद मैम कब चेक करेगी? 15 पे चेक करेगी. नेक्स्ट मैम कब चेक करेगी? 20. और लास्ट मैम कहाँ पे स्टॉप करेगी? 100 पे स्टॉप करेगी. तो मैम एवरी मिली सेकेंड पे वोल्टेज चेक कर रही है क्या? नहीं. मैम क्या कर रही है? मैम डिस्क्रीट टाइम पे चेक कर रही है. तो मैम को यहाँ पे क्या लगेगा? मैम को यहाँ पे इंटरवल लगेगा. तो मैम ने इंटरवल क्या चूज किया? Is this clear to everyone? So that is what we mean by discrete time signal and continuous time signal. So a discrete time signal, you will see a square wave kind of thing, right? But then for a continuous type of signal, I'll see a complete analog kind of thing out here, right? Clear to everyone? Is there any confusion in this?
No.
No. Okay. So this is the example for a discrete time signal, wherein I take the signal at signals for a certain specific values of time, right? Typically, they are equally space points in an interval. That's what I touched upon, right? So हर interval पे मैम हर एक interval पे मैम check करेगी. मैम हर बार नहीं check करेगी. Example is number of stocks traded per day, right? ये number of stocks traded per day ऐसा नहीं होता है. ऐसा देखा है क्या किसी ने स्टॉक मार्केट का? Have you seen
No.
any? No. We see an output like, okay, so 9 a.m. पे ये था, 12 पे ये हुआ, फिर उसके बाद में 2 पे ये हुआ, फिर 3 पे ये हुआ, so on and so forth, right? So these are discrete time signals in that case. So that's a very good example for stocks. Can I have one more example for stocks? For discrete time signal? Average income per province is also a good example for discrete time signals. Can I get one more example for stock for discrete time signal? कोई भी example. कॉन्टिन्यूस के मेरे पास बहुत एग्जाम्पल है, मेरे को डिस्क्रीट का एग्जाम्पल चाहिए. कॉन्टिन्यूस का मेरे पास ऑडियो है.
COVID cases.
Okay, good. So she wants to say that COVID cases state wise, whatever, right? COVID cases per state. Okay. And COVID cases per day. I can get that also. Anything else that we can touch upon when I talk about discrete time signals?
Volume increase and decrease.
Volume as in the way we speak. Audio.
Population.
Good. Population could be another example. Yes. Yes. So these are my discrete time signals that will be processed by my DSP. Clear? Right? So analog signal समझा सबको? What is analog signal? What is analog signal? ये analog है? ये left वाला?
Yes, ma'am.
Is this analog?
Yes, ma'am.
Okay. Why am I saying this analog?
Because it's not
Continuous.
consistent. The waves
No.
are not
Consistent.
consistent.
Consistent nahi, हाँ. How am I saying that this is consistent and this is not consistent? Because it is continuous in time and it is continuous in amplitude. Got it? Analog signal is continuous in time. I take it for every millisecond और जो भी time frame मुझे दिया होगा, मुझे हर एक value के लिए, हर एक independent variable के value के लिए मुझे उसका signal का value चाहिए. So that is continuous time and continuous amplitude. But what happens to a digital signal, students? It is discrete in time. एक specific interval पे ले रहे हैं हम लोग, right? और उसका output भी एक discrete amplitude है. Clear or no? राइट. सो पार्टली यू आर करेक्ट कि कंसिस्टेंट नहीं है. कंसिस्टेंट क्या नहीं है? कंसिस्टेंट अगर मैम ने यहाँ पे इसका इनपुट, इसका एक्स का वैल्यू चेक किया तो ये आएगा, इसके बाद चेक किया तो ये आएगा, नेक्स्ट चेक किया तो ये आएगा, राइट. सो आई एम गोइंग टू गेट द एम्पलीट्यूड एज नॉट अ फिक्स्ड वैल्यू, बट देन इट्स अ रैंडम वैल्यू एट सम प्लेसेस. बट फॉर डिजिटल सिग्नल, माय डिस्क्रीट टाइम, दैट इज द इंटरवल्स आर देयर. I don't take it at every point in time, and my amplitude is also discrete. राइट. फिक्स्ड एम्पलीट्यूड है, मतलब यहाँ पे 3 रहेगा तो 3 ही रहेगा, यहाँ पे 2 है तो 2 ही है, यहाँ पे 1 है तो 1 ही है, राइट. सो दैट इज द डिस्क्रीट वैल्यू, डिस्क्रीट एम्पलीट्यूड. आई होप यू नो व्हाट इज द एम्पलीट्यूड ऑफ अ सिग्नल. व्हाट इज एम्पलीट्यूड? एम्पलीट्यूड क्या होता है? अच्छा, अब मैम ने ये सिग्नल ड्रॉ किया है ना, इसमें टाइम तो ये है, एक्स एक्सिस है, और y क्या है आपका? सपोज y इज माय x ऑफ t, राइट, एंड दैट इज द वोल्टेज. ठीक है, तो इसमें एम्पलीट्यूड क्या है? ये जो वैल्यू है ना, ये एम्पलीट्यूड है. अग्री? नो? डू यू नो दिस? Amplitude is the length of the signal. At any given point in time, what is the value of that signal? No, that is the amplitude of the signal. Clear?
Yes, ma'am.
Clear, no? Right. So that is the amplitude. So analog signal में जो amplitude होता है वो भी continuous होता है. Digital signal में जो amplitude होता है वो discrete होता है. मतलब यहाँ पे अगर मैम amplitude लेगी ना तो मैम को 3.2, 5.6 suppose, I get 8.9 ऐसा amplitude आएगा क्योंकि वो continuous amplitude है. But मैम discrete amplitude लेगी तो क्या आएगा? मैम को confirm 3, राउंड नंबर्स, राउंड ऑफ नहीं आएगा मैम को, फिक्स्ड इंटीजर वैल्यूज आएगा, 3, 5, 7, 9, समथिंग ऑफ दैट सॉर्ट. इज दैट क्लियर टू एवरीवन? एनालॉग सिग्नल्स एंड डिजिटल सिग्नल्स, राइट. राइट. सो एनालॉग सिग्नल्स के लिए, एनालॉग सिग्नल्स आर द रियल वर्ल्ड सिग्नल्स which is analog in nature. Digital signals, because I'm going to use digital signal processing, which have got their practical applications, and wherein I'm using my DSPs to process my digital signal, basically, right. And we are going to stop here, and we are going to touch upon what is a signal, and how do I measure it basically in our next lecture, because analog part is very essential for you to understand, so that we proceed further. When if you want me to keep the ink annotations and then I forward the presentation to you.
Yes.
Yes, ma'am.
Okay. Okay, so I'll be just forwarding this presentation to everyone out here and post the session. And till the time, if your classroom links are available, then I'll be posting